So there's three ways that you can represent these aqueous reactions. You can do the molecular equation, which is going to show the complete neutral formulas for every compound. This is what we have been doing previously. So here, I'm going to use the same equation, and we're going to take it down in all of these forms. So here, if I have nickel 2 chloride aqueous plus sodium sulfide gives us nickel 2 sulfide, which is solid, to NaCl, which is aqueous. This is what I've been doing. You just do your double replacement and then use your solubility rules to determine whether you have a precipitate or not. Next, you can have the complete ionic equation. Rarely are you going to have, is something going to ask you just for this. It shows all the species as they are present in the solution. So that's going to take your reactants and you're going to break them apart into your ions. So that would show nickel breaks apart, and then go ahead and say 2 chlorides, and I guess we should say all these are aqueous. And sodium, there's 2 of them, it's aqueous, and S-2 is also aqueous. And then on the other side, we're going to have our nickel sulfide, which is solid, and our sodiums remain in solution, and our chlorides remain in solution. Now, these here that are ions in both sides of the equation, so see how these stay as ions in both sides? These are called spectator ions. They're there, but they don't participate in the reaction because they're ions on both sides of the equation. They're ions in the reactants, they're ions in the products. Now, the net ionic equation actually shows only the species that actually change during the reaction when you mix these two solutions together. So here we had our molecular equation. Everything is a compound. Here we broke apart what was in solution versus what was not in solution. Now the net ionic equation, its job is you're going to remove all of your spectator ions. So anything that stays the same on the left and the right is gone. So your net ionic equation here would be, these two start out as aqueous and then they snowflake out. So that's your net ionic equation. So for me, in order to get from a molecular equation to a net ionic equation, I generally have to go through this. This is kind of a progression for me. Hopefully you find that helpful.